So today we'll create a CLI that will open up a web browser, perform a search, and will show the results in the command line. So in short, we can call it a web scraper that searches through Google or YouTube or WikiHow, Wikipedia, Bing, or any of those searches. In the process, we'll learn about how to perform depth first search in the HTML tree, and we'll learn how to perform web automation using Chrome DP in Golang, and web scraping using HTML package. We'll learn how to create a simple CLI, and the most important thing is we'll learn how to use interfaces to organize code. So what we'll do here is we'll create a search manager struct that will have various functions to open web browser, perform search and show results, and perform DFS and all those things. The things that are specific to Google, YouTube, DuckDuckGo, or any other search engine, YouTube, anything, will be passed here as a searcher interface. So these structs will implement that structure interface, and any of them can be passed inside the search manager class to perform the operations. In the project structure, we have to deal with majorly three things: the CLI part, which is fairly easy with the flag package in the Golang, and the browser automation part. The first one will be initialization of the search manager. Then we'll perform the search and get the results HTML, and then we will parse that HTML and find the links and the titles. Only two things will be displayed in the CLI: the link of the search result and its title. So anyone can just open the link if it finds interesting in the command prompt or its terminal itself. So let's start with the code. Here I'll organize the code with the two main folders, the CMD and the package. Before that, I'll initialize the project with Go mod in it, and then the command will have the executable scripts, and the package will have the helper scripts. This is the convention is in most of the Golang packages, so I'll use it here as well. So first we'll create the search manager. So now this search manager will perform something. To open the browser and perform web automation using Chrome DP, we need something known as context. So this search manager will have that context, and also it will have the searcher interface, like any struct that will implement searcher interface. So we'll create the searcher interface in the common.go package. So there are a few things that the search manager would do. The first thing is we need to initialize the search manager. So it will take two arguments. First is the searcher interface, like any struct that implements searcher, and the second will be a boolean value known as headless. If a headless is true, the browser automation will be performed in the background, and if it is false, it will be shown on the screen. So to use this Chrome DP, we need to go get this. I'll be doing it with the go mod tidy command. So it takes in the context that I'll pass in as context.background. So to allow it to be headless or not, we'll have to add a flag, and we'll set its value to the parameter passed from the command line. And we'll also change the window size, because oftentimes if the default window size is pretty small, and sometimes the elements are not properly rendered. So I'll change that too to avoid any errors. Okay, and as for the cancel function, it is the function we need to call to stop this context. I mean, to cancel this. So we will need this to stop the browser if there is any error or something goes wrong. So I'll capture all these cancel functions in a array. I'll show you how I'll use it. So at the end, I'll use it to call all these cancel functions. I'll show you how. we'll also need to add a certain timeout to the function so that it doesn't goes on indefinitely. So at max a function would go on for 15 seconds, I suppose. So I'll set that timeout for 15 seconds, and then I'll also cancel funcs append cancel, and finally we'll convert this context into the ChromeDB context. New context, and at the end I'll define a cancel function that will call all these cancel functions. Okay, so this cancel function will call all these cancel functions, and this cancel function will be present in the search manager struct. This cancel will be called in case any error is occurred or something, or in any ways if we want to close the browser, we'll just call this cancel function, and we'll simply return the search manager with the context as ctx and searcher to be s. Fine, so we completed this new search manager function, this first part. So that the next thing we need to do is to perform the search operation here. So the search will take a query, a string, and it return an error. So for this we'll simply call the chromedb.run function, and we'll pass in the context, and then first we'll navigate to the website. So the website will be provided to us by this searcher interface. We'll define a website function that returns a string. I'll just show you a demo of the website. Let's say we want to perform an automated search on the Google. First it will go into this website, then it will click on this search box, and then it will perform the typing of the query, then it will press enter, and that will lead us to the result page. And here we'll just filter out these results, the smallest div that contains results, and then we will find out the links and the titles of the results that we need. And so this will be how will work. So the next thing we have to do is to click on the search bar. The search XPath will also be provided to us by the searcher. So we'll initialize another interface method. So this will be used here. And after performing the click, we need to type in some things. So we'll use the chromedb.send keys, and again we'll use the same search path, and we'll type in the query, and at the end to simulate and enter, we'll add in a new line character. Fine. So this will lead us to this search result page. So now we need to filter out the results section here. So this will be, yeah. So this div has all the results. This XPath will also be given to us by the searcher. Like for Google it will be different, and for DuckDuckGo it would be different, and so on. The result XPath. So we should wait in here for a few seconds to allow it to fetch us the results. We'll wait till for 2 seconds, we'll sleep for 2 seconds, and then we'll extract the inner HTML. We'll add in the selector as the result XPath, and then we'll extract the results into a string. So I created this res HTML, and we'll store our resulting HTML into this. So this HTML source will also be present in the search manager struct, and then we'll just assign this. So now we completed our search function. Now before moving further, we should first try to create a concrete type of this searcher interface to see whatever we have done is working or not. Now as for the website, I'll just copy this and return this. And as for the the search XPath, I'll just copy this. I'll copy the full XPath and return. And similarly with the result XPath, closest XPath we can get is of this. So I'll just copy full XPath and return this. And I'll create a main function that will test if this works or not. I set headless to false so that we can see what is happening in the browser automation. And let's see how this works. So it opened up the Google and we haven't called the cancel function, so it didn't close the web browser. And for the time being, I can also show you the HTML it extracted. Let's see. Here's the HTML. Now our next task will be to parse this HTML and get the results. Now our next step is to convert the HTML string into a tree form so that we can iterate over it and get the links and the titles that we need. So to store the error, we will create a new struct with the type result, which will store the link and the title of each result. The first thing we'll do is we'll call html.parse function. So for that we are using x/net/html package. This function takes in an IO reader. So to convert a string into IO reader, we simply have to use strings.newReader function and we'll pass in the string. And this function returns us the HTML node and the error. So I'll call this as root node. So after getting the root node, we have to iterate over this tree. So to iterate over this tree, we'll use an algorithm known as depth first search, DFS. So for that, we'll create a function. We'll call that function pass, and this takes input an HTML node and returns a result slice. And inside this, we'll just append the results from the parse function, and we'll call it for the C as well. So this is a recursive call, and at the end we'll return results. Okay, so here we need a way to find if a link is the valid link or not. That means, is it the link which contains the actual result and the title? So for that we need the function which will be provided by the searcher interface. Each searcher struct would provide us with a isCorrectLink function that will take in an HTML node and provide us with a Boolean value. So one thing with the child node, the HTML node, is that the attributes it gives is in form of list. It is oftentimes convenient to convert it into a map, and then the isCorrectLink function could easily identify if the node is a correct link or not. So we'll create a map. So this also should be passed into the isCorrectLink function. The searcher struct would also provide us with a function that will extract the link and the title from the link node. So now we'll extract the link and title using the function, and we'll add the result. So this is completed. So this will recurse through all the nodes, and if it's the current link, it will extract the link and return the results. This will get the results. So now, since we have completed our parse function and the get results function, we need to ensure that every searcher should implement these functions as well. So now let's implement the isCorrectLink function and the extractLink title function for the Google searcher. So I just committed one mistake, that before checking if the link is correct or not, we should first check if it is a link anyways or not. So I'll just check if it's an anchor tag, and then only it will check if the link is correct or not. This was a small correction. So to check if this anchor tag is the correct one or not, what pattern we can see is that every link of the result has these attributes: JS name, JS action, JS controller, data vet. Fine. So we can use this thing to check it. So this logic loops over all these strings, and it checks if this attribute was in the attrs map or not. If any of these attribute is not there, it will simply return false, else it will return true. So now for the extract link and title function, so we can see that the child node with the h3 tag, it has the title we need. You can check in other this as well. Inside this anchor tag, there is an h3 tag which has the title introducing ChatGPT here. Fine. So we can use this technique. So attributes with href has the link, and the child with the h3 tag has a child which would be a text node, and that text node has the data that we need. So now let's check this go main function if it works correctly or not. And for our use, we'll also print the results of. So here it shows the title and the link. So if I just open up any link, it will show the link that the search result 2 + 2 = 5. This could be an interesting video, but not now. To print the results in a better format, I'll just loop over it and so to check for the errors, I'll just create a check function that will take an error. Maybe I should just increase the deadline. So let's change the duration, timeout duration. I suppose the error is due to the selection path, the search result path. Yeah, here we are. This is the title and this is the link. Title, link, title, link. So this function works for Google. Now I'll show you the power of using an interface. How we can expand this to search for the YouTube as well. So first, so we can simply copy these things and just replace. So I'll just change this to YouTube searcher. So let's copy this and append it to YouTube, and we'll search path. I'll just copy full X path, and as for the search result, so this is the full X path for the YouTube search result. Now to check if the link is correct or not, let's see how we can do that. This link tag. So if the link tag has the ID video title, let's try this. We don't need to check for all these things. If attributes ID is equals to video title, and for this title, if you look closely, there is a title attribute as well in this. So we can simply return. So the href tag here is starts with slash. So that means it is a relative path to the youtube.com. So we have to create that link in that way. Fine. So the website doesn't ends with the slash. So what we can do is we can do g.website and append it with the attributes of href. This will be our link, and attributes of title will be our title. This was fairly easy, I suppose. There's the other. Okay, or we can just simply return this. So this I think is easy. All we need to do is just change the YouTube searcher. Just call YouTube searcher here. Let's see if it works fine or not. So I think I know the error. In YouTube, when the search box is clicked, it has to wait for some time for it to render properly. So what we can do is, after the click, we can write a small sleep function. Let's see if this works. We can do is write a sleep for time dot. Let's try to. With just a small change, which is also working for YouTube. So I can also create a CLI. Here are the search results from Google, and here are the search results from YouTube. We can make these calls concurrent by using coroutines, but I think this is enough for this video. Thanks for watching.